Good day and welcome once again to our class on real analysis. In today's class, we'll be talking about monotone or monotonic sequence. Monotone or monotonic sequence. A sequence A sub n is said to be monotonic or monotone if it is either increasing or decreasing. If it is either increasing or decreasing. Therefore, a monotonic increasing sequence, is such that the first term of the sequence A1 is less than or equal to the second term, that is less than or equal to down to less than or equal to the nth term an, which is less than or equal to a sub n plus 1. Therefore, for a sequence to be monotonically increasing, an must be less than or equal to a sub n, and this is the same thing as saying a sub n plus 1 must be greater than or equal to a sub n. If we divide both sides by a sub n, it still gives us what? It is still equivalent to a sub n plus 1 over a sub n to be greater than or equal to 1. Or if we bring this here, subtracting a sub n from both sides, we have what? A sub n plus 1 minus a sub n to be greater than or equal to 0 for all n belonging to the set of natural numbers. If we want to determine whether a sequence is monotonically increasing, we can use any of these to find out whether the sequence is monotonically increasing. Also, a monotonic decreasing sequence is such that, now since it is decreasing, the first term A1 will be greater than or equal to the second term A2, which will be greater than or equal to the third term A3, and this will be greater than down to greater than or equals to an, which will also be greater than or equals to a sub n plus 1. Therefore, as we said here, for a sequence to be monotonically decreasing, then a sub n must be greater than or equal to a sub n plus 1. And this is the same thing as saying what? A sub n plus 1 is less than or equal to a sub n. If we divide both sides by a sub n, we have an equivalent form, which is a sub n plus 1 over a sub n to be less than or equal to 1. And if we subtract a sub n from both sides, we have another equivalent form, which is a sub n plus 1 minus a sub n to be less than all n contained in the set of what? The set of natural numbers. Now, whether a sequence is monotone increasing or monotone decreasing, we simply say that what? The sequence AN is monotone. Let's put that down. Note, whether a sequence AN is monotone increasing or monotone decreasing, we simply say that the sequence A sub n is monotone. We simply say that the sequence A sub n is monotone. Also, we can have strictly increasing sequence and strictly decreasing sequence. A sequence A sub n can be strictly increasing or strictly decreasing. What happens when AN is strictly decreasing? The sequence A sub n is strictly increasing if A sub n plus 1 is greater than A sub n, and it is strictly decreasing if A sub n plus 1 is less than A sub n. However, a sequence can be monotonically non-increasing or monotonically non-decreasing. To have a sequence that is monotonically non-increasing, and monotonically non-decreasing. An example of such is the constant sequence. Example is the constant sequence where A sub n plus 1 is equal to A sub n for all n in the set of natural numbers. Now we'll take examples. Consider the sequence A sub n defined as what? N, as n moves from 1 to infinity. What are the terms of the sequence? 1, 2, 3, 4, and so on. We can see that this sequence is what? Monotonically increasing. This sequence is monotonically increasing since A sub n plus 1 is greater than or equal to A sub n. So we know that what? It is monotonically increasing. How about we consider the sequence of the square of numbers. And then moves from 1 to infinity. The square of numbers. What are the terms of the sequence? 1 square, 2 square, 3 square, 4 square, and the likes. And that gives us what? 1, 4, 9, 16, and so on. Also, this is a monotonically increasing sequence. This is a monotonically increasing sequence since what? A sub n plus 1 is greater than or equal to a sub n. A sub n plus 1 minus a sub n is greater than or equal to 0. Let's consider the sequence of reciprocals of numbers. Consider the sequence of reciprocals of number. The sequence an defined as 1 over n as n moves from 1 to infinity. The terms of the sequence are 1, 1 over 2, 1 over 3, 1 over 4, down. We can see that for this sequence, a sub n plus 1 is less than or equal to a sub n plus 1 minus a sub n is less than or equal to 0. Therefore, this sequence is monotonically decreasing. Now let's consider the constant sequence 5. The constant sequence 5. Here, we see that a sub n plus 1 is equal to a sub n. Therefore, this is a monotonically increasing or non-decreasing sequence. It is a constant sequence. Constant sequence. It is a constant what? A constant sequence. We also have other type of sequences that we can refer to as non-monotonic sequence. There are other types of sequences. The first one, I said it's what? The non-monotonic sequence. There are other types of sequence. We have the non-monotonic sequence. These are sequences that are neither increasing nor decreasing. Example, the sequence an defined as what? N squared over 2 raised to power n. What will be the terms of that sequence? The first term will be 1 over 2. The second term will be what? 2 raised to power 2, that is 4. 4 over 4. The third term will be what? N raised to power 3. I mean 3 raised to power 2 rather, that is 9 over 2 raised to power 3. That is 8. The fourth term will be what? 4 raised to power 2, that is 16 over 2 to power 4, which is also 16. And it continues like that. What do we see from here? We have 1 over 2, 1, 9 over 8, 1, and like that. We can see that what? This is a monotonically non-increasing or non-decreasing sequence. It is oscillating. Another example that we can have is the sequence an defined as minus 1 raised to power n. What are the terms of this sequence? The first term minus 1, the next one 1, the next one minus 1, 1, and it continues like that. You see that what? These are oscillating, and because they are oscillating, It tells us that they are neither increasing nor decreasing, therefore they are non-monotonic sequence. Therefore they are non-monotonic sequence. We have the ultimately or eventually increasing sequence. These are sequences that may initially decrease. They may initially decrease, but after some number of times, it begins to increase. And then continues to increase. A graph of such sequence will look like this. It was first decreasing, and then it begins to increase, and it continues to increase. That's a monotonic, an ultimately or eventually increasing sequence. You can think of an example of a sequence that follows this pattern. Let's go to ultimately or eventually decreasing sequence. Ultimately or eventually decreasing sequence. These are sequences that may initially increase, but after some time or after some number of times, it begins to decrease and continues to decrease. A graph of such sequence will look like this. It initially begins to increase, and then it started decreasing, and it continues to decrease. That is eventually decreasing sequence. You can think of examples of sequences that are ultimately increasing or ultimately decreasing, and give your answer in the comment section. We are going to stop here for today's class. In the next video, we'll be looking at how to prove that a sequence is monotone. If you have gained anything from today's class, give it a thumbs up, like it, and share with your colleagues so that they too can benefit. Thank you. God bless you. I see you in the next video.